in this question, we've been asked to find out how many lead atoms are there when there are a given number of moles of lead atoms. We've been given a number of moles, and we've been asked to give our answer to 2 decimal places and in standard form as well, when necessary. So in this case, one of the questions we would have is, well, do we need to use the periodic table in order to work this out? I mean, they tell us it's lead, they tell us the number of moles of lead, and we're asked to work out the number of atoms. So do we need the periodic table? Is it necessary to work out the answer? So I'd like you to, well, I invite you to reflect on that, whether we do need a periodic table or not. I mean, you can see we've got lead here, and then on the periodic table here we can see that we've got lead here. But you know, the question is, well, do we need this for this question? Actually, the answer in this case is no. We don't need the periodic table to work this question out, right? And primarily why we don't need the periodic table is the equation we're actually working with here is that the number of particles, right? Number of particles is equal to the number of moles multiplied by the Avogadro constant. So that is going to be, I mean, in long form, obviously, Avogadro constant. But in short form, that would be N, capital N, A, right? Avogadro constant. As we can see in this equation, there is no mention of really the need to use for example, the relative atomic mass or anything like that, right? So actually we don't need the periodic table. You might find this equation represented, maybe it's like something like in the triangle, particles, and then with the 2 at the top, right? It's the number of moles. Multiplied by so sometimes you might find something like this, approximately. Yeah, let me just fix that a little bit. But yeah, that's you might find something like this. But anyway, long story short, we don't need the actual periodic table to work out the answer. But what we do need to do, 4.39, right? Get the number of moles. And as per this equation, we're going to do 4.39 multiplied by the Avogadro constant, which is given in the question, 6.022 times 10 to the power of 23. So times 6.022 times 10 to the power of 23. And as the question does make clear, this is just what the Avogadro constant is to 4 significant figures. It's obviously not the entire, the entirety of the constant, right? But I'd invite you to try and work this out on your calculator. And if you do that, what you should find is you get 2.643 658 times 10 to the power of 24. Now, at this stage, it is quite important to look at what has actually been asked in the question, as to not make a mistake. So, although this is approximately, we're close to the answer, we do need to make sure that it does conform to the required number of decimal places. In this case, what's been requested is to 2 decimal places, so we would need to round this, so the actual answer would be equals 2.64. 2.64 times 10 to the power of 24, right? So that would then be our answer, right? Okay,